Okay, Assalamualaikum to Dr. Muhammad Zulkarnain. Okay, today we are going to present our grade assignment, which is the fundamental of cooling tower for BMMH 2503, fundamental of HVAC and refrigerant. We are from group 1 from 3 BMMVS2/1. Okay, first thing first, I want to introduce myself and my friends. My name is Muhammad Shahid Amel bin Shahidan. And my friends Muhammad Ahmad Izzat, Wang Keng Peng, Akmal Zakwan, Nur Akilah, and Nur Atika. Okay, for introduction, as we know, an industrial cooling tower can be larger than an HVAC system and used to remove the heat absorbed in the circulating cooling water system. Cooling tower also a device that removes heat from a process by transferring it to the atmosphere through the use of water. Cooling towers, including commercial and industrial cooling towers, work by evaporating a small amount of water that is recirculated through the unit to remove heat from the water. Okay, there are many types of cooling tower, such as natural draft cooling tower system, mechanical draft cooling tower system, cross-flow cooling tower system, and counter-flow cooling tower system. And mechanical draft cooling towers are the most widely used in buildings. They are normally located outside the building. And the two most common types of mechanical draft towers to the HVAC industry are induced draft and forced draft, as we can see in the picture.
Alright, thank you, Shahid. My name is Wang Keng Peng, and I will continue this presentation with components of a cooling tower. So, as you can see, there's a lot of complicated components inside a cooling tower. We can know how the water, hot air, and cold air flows in its direction as well in this picture. Shortly, a general cooling tower normally consists of 5 basic components, which are cooling tower fan motor, cooling tower nozzles, distribution valve, drive shafts, and gearbox. So, next, for the method and data, here's the observation table from one of the general cooling tower that small factory usually use, which includes the watts, frequency, water temperature, bulk temperature, number of CT cells, water flow, and fan flow in meter cube per hour. Then, this is the types of refrigerants or coolant that we use inside a cooling tower. As you can see, there's 5 types of fluid that usually used, which is water, ethylene glycol, propylene glycol, dilene HC30, Guidon HT200, and Fluorinated FC72. So this cooling tower's fluid with big range of cost difference seriously affect its thermal conductivity, specific heat, viscosity, density, boiling point, and freezing point. You can see that there's more expensive for the fluid, the less the thermal conductivity and its freezing point as well, which means the more cost is used, the more efficient the fluid inside the cooling tower. So that's all from me. Now I'll pass the presentation to Akmal Izzat. Thank you.
Thank you, Wong Keng Peng, for your explanation. And now, for my part, I will explain about the
Installation.
Installer need to select the best place on the building to install the tower. Ensure that it is placed within the flows of the natural winds in the building site. Acoustical strategies of the design of the space and other features around. Ensure that the system of the building is well built and strong enough to support the towers. And lastly, invite an engineer or architect for them to go the ahead. For the next part of installation, other installation details that are need to check and confirm, which are installation of the component of the cooling towers, install a water distribution device, installation of the ventilation equipment, and lastly, installation of the cooling tower drift eliminator.
Result and analysis for formula. Number 1, m.air. This is a formula. Number 2, m.wi. Number 3, m.wo. This is a formula. Number 4, m.ai. 5, m.wi. 6, m.wi plus m.mvi equal to mwo plus mvo. Number 7. M dot makeup critical equal to M dot air times W out and WI. Number 8. M dot makeup equal to P times V but divided by 5 minutes and divided 1.0 exponent C ml divided 60 seconds times 1 minute. Number 9. T approach plus 2 equal TWO minus TWBI. Number 10. Omega I equals CP times TWB minus TDB plus W out times HFGWB divided by HGTB minus HFWB. 11. Omega. Number 12. M dot A times H1 plus M3 times H3 equal MA times H2 plus M4 times H4. This is an example. Number 13. 14 energy I and 15 energy out and 16. Q equal MWO times H4 plus MWI times H3.
Hi, I'm Akila and I will be presenting the results and analysis of our assignment, cooling tower. There are actually two major parts in this part, but I will be going through it one by one. So first of all, the flow chart cycle that happens in the cooling tower. The water flows through the cooling tower pipes. The hot water is then recirculated and exposed to the cold dry air to be evaporated to remove the heat. The colder water is then returned, entered through nozzles into a bank of material called fill. The fan that takes in the air from the bottom and then pushes it upward. The evaporating water will transmit the heat from the cooling tower into the air. The water and air will meet, and then a small amount of water evaporated. It is the cooler to cool the air. The cold water is then sent back to the condenser and being pushed back to the cooling tower to be cooled again. So the next part is the phase changes. This is the major point that affect the phase changes. First, the wet bulb temperature is very crucial for evaporative water cooling. As we know, evaporation is the major process that happens in the phase changes. Evaporation is the process of removing heat from the liquid water to make it colder. The heat rejection device that cools the air from inside before releasing it into the atmosphere. The cold water circulates around the coil and then the heat is transferred from the fluid to the coil. Next, this is the graph that for the temperature versus the percent distance through the temperature. There are actually 2 points, which is point A to point B and then point C to point D. Point A to point B, the phase is water. As you see, the temperature pattern is declining. Meanwhile, point C to point D, the phase is air. As you can see, the pattern temperature is increasing. That's all from me. Thank you.
Assalamualaikum. My name is Nur Atika binti Waziri. So for this assignment, we choose a cooling tower for our topic. So for the discussion, we talk about the principle of cooling tower. Cooling tower are circulating water system used to remove heat from industrial processes and commercial heating and air conditioning system. Water is utilized to collect and discharge waste heat from a system, mostly through evaporation in cooling tower system. Prior to flowing through a heat exchanger, water absorbs heat. The water then distributes around the top of the cooling tower, where air flows over the warm water, evaporating some of it. Then the heat transfer from the water stream to the air stream raises the temperature and relative humidity of the air to 100%. The warm air is discharged into the sky and cool water in the basin is then recycled. For the cooling tower, the proper tower size must be chosen to maximize the benefit of water-based cooling tower. For cooling tower low cost, as a cooling tower are low cost as well known for their ability to remove waste heat. For the conclusion of this cooling tower is, a cooling tower job is to cool water that has been heated by industrial equipment and operation. The water enter the cooling tower hot is from the industrial process and then leave it cool, then back into the industrial process. So students learn about the purpose and inner workings of cooling tower for various applications. So for me, and my group. Thank you.